Alright, if we went too fast today during the lesson, or you need to go back and look at the steps again, pause the video and jot down the steps. I'm going to rework the examples because I felt like I rushed so much today in class. And then I skipped some, so I'll rework all the examples. Maybe hear it again can help you if you're having a hard time with your assignment on U-Substitution. Okay, so what we're going to do is for each one of these go through the steps. And the first step is to determine what the inside function is, and in this case it's 3x minus 4. So we're going to set u equal to that. So the next step is to find the derivative of u with respect to x. And then solve for du. So each time we're solving for du, we're multiplying by dx. Alright, so what we'll do now is just kind of check our integrand. Our integrand has to have the whole part of du, and it has to have 3 dx. And it doesn't have the 3. So we'll multiply by the 3, but to keep it as a scale of 1, then we're going to have to, in front of the integral symbol, multiply by 1/3. Alright, and then I'll just rewrite this. So our next step is to rewrite this in terms of u. So after this step, in our integral, we shouldn't have any x's. So because u is 3x minus 4, I can rewrite that as u to the 5th. And then because du is 3dx, I can rewrite that as du. Alright, so now we're ready to find the antiderivative of 1/3 times the integral from, 1/3 times the integral of u to the 5th du. So that is going to be the power property for antiderivatives. So that 1/3 is going to hang out for a second. When we do the antiderivative with a power, we are going to add 1 to the exponent and divide by that. So it's going to be 6, so we'll do 1/6. And then that is also your new exponent. And don't forget, when we're doing indefinite integrals, we have to have the plus c. Okay, and then I'll go ahead and multiply that 1/3 and 1/6. And then since we are doing indefinite integrals, we need to do the step where we take what u equals and replace it with it. So u is 3x minus 4. So this is our answer. All right, let's go to the next one. On this one, we need to look at it and figure out what u is. Our inner function is going to be 7x. So the derivative of that with respect to x is 7. So du is 7dx. Alright, so we are missing the 7. So I'm going to multiply by 7. But to counteract that, I have a 1/7 on the outside. Alright, so I'm going to rewrite it with my changes applied. then I'll write this integral in terms of u. So everywhere where I have a 7x, I'm going to change that to u. And we already know 7 dx is du. Right. Then I'm going to find the antiderivative. So the antiderivative of secant of u tangent of u du is going to be secant of u plus c. And then on this one, my last step is just to take u and replace it with what it equals. And in this case, that's 7x. This one, some people today kind of struggled a little bit figuring out what the inner function was, but it is going to be this exponent. So u is x to the 4th minus 2x, which makes the du over dx 4x cubed minus 2, which is convenient because that is in our problem. That is in our integral, which is exactly where we wanted it. So I'm going to rewrite it because I think sometimes when you first start doing this, it helps if you see the du all together. Now, if you don't have to do this step of rearranging your multiplication, it's fine. It's great if you don't have to. But sometimes when you're first learning it, it helps to see it like this. All right, so we're ready to write this in terms of u. So x to the 4th minus 2x is u, and 4x cubed minus 2 times dx is du. And then whenever we find the antiderivative of e to the u du, it's going to be e to the u plus c. And our last step is to take what u is and plug it in for u. So e to the x to the 4th minus 2x plus c. Okay. So this next one, our inside function is going to be x cubed plus 1. The derivative of that with respect to x is 3x squared. Now you can see in the integrand that you already have your x squared. So I need a 3, so I would multiply by that 3 and counteract that by 1/3 multiplied on the outside. All right, and again, I'm going to rearrange this. I'm also going to write my square root with a power of 1/2. Alright, so I have that x squared in the front, I'm multiplying by 3 on the back, so that's going to be 3x squared dx. So I'm ready to write this in terms of u. So we're going to have u to the 1/2 du. Alright, this is one in class I felt like I went really, really fast and some people got a little confused. So this was one I definitely wanted to rework. So I think you guys are doing really well with the new power rule for antiderivatives. This one just got a little confusing. So we're going to add 1 to 1/2, and we are going to get 3/2. But don't forget that when you use this power rule, you're dividing by that new power. So when we divide by 3/2, you multiply by the reciprocal of it. Right? It is also your new power. Not the reciprocal of it, that actual, what you got when you added the 1 is your new power. Alright, and then finally, we can go ahead and multiply the 2 fractions together and replace u with what it is. And that should be it. Alright, so number 5 we didn't have a chance to do in class. So you have several sine and cosine problems you have to do on your assignment, so I do want to go back and do this one for you guys. So u, in this case, the inside function is going to be 3x squared. Du is going to be 6x. Du over dx is going to be 6x. Du is going to be 6x dx. So we have the 3x, we want 6x, so we are going to multiply by 2. And then in front, we have to counteract that by multiplying by 1/2. Right, and then I'm just going to rearrange to move the 6x to the ends. Then I'll take my integrand and I'm going to rewrite it using only u. So since u was 3x squared, I replaced it. And then because du was 6x dx, I replaced it. And I'm ready to find the antiderivative. The antiderivative of sine of u is negative cosine of u plus c. Then we'll take what u is, plug it in, multiply negative 1 times 1/2, we get negative 1/2 cosine of 3x squared plus c. Okay, and then the last one, we're going to rewrite it because we don't have a rule for tangent of x yet. We're going to discover it right now. So when we're finding the antiderivative of tangent of x, we can rewrite that using a trigonometric identity that the tangent of x is equal to the sine of x over the cosine of x. Alright, and then these sometimes can get challenging when you have these fractions trying to decide what's the inside and outside, and they really do kind of change from problem to problem. So try it one way, if it doesn't work, try it another way, and eventually it's going to all kind of start making sense to you. So u, in this case, and in a lot of the cases, u is some form of the denominator. And I'm not going to tell you it's always that way because there definitely are times when it's not. But in this case, u is going to be cosine of x. So du over dx is going to be negative sine of x. And du is going to be negative sine of x dx. Okay? So I'm going to kind of mess around with this one a little bit, and I hope it doesn't confuse you. The only thing it's missing is a negative to have the whole du in the integrand. So I have a negative here and a negative here. So I'm going to rewrite this as 1 over cosine of x du. Now, we could also have written that as du over cosine of x, and some people like that better. So that's another option. Oh wait, hold on. That's not right. Just kidding, just kidding, just kidding. Alright, when we're ready to write this in terms of u, u is cosine of x. So u is going to go on the bottom. And then negative sine of x dx is du. So you can either write that over to the side, or you can write it as du over u. It doesn't matter to me which way you do it. To me, to do the next step, it kind of makes a little more sense to write it the first way I wrote it, but figure out which way makes more sense to you. But I just replaced cosine of x with u because that is what u is. Okay, so now we have to find the antiderivative of 1 over u. And the antiderivative of 1 over u du is the natural log of the absolute value of u plus c. And that's going to work for the other way if you write it the other way also. Alright. And then what we'll do is plug u in. U was the cosine of x. So that is the rule for the antiderivative of tangent of x dx. It's going to be the negative natural log of the absolute value of cosine of x plus c. So it's another thing we're going to need to make sure we memorize. Now, if you forget it and you have plenty of time, you can redo what we just did, but memorization would be a little easier for us, I think. All right, so, if you weren't here today and you need to know your assignment, it's that worksheet, just the front side of that worksheet, just numbers 1 through 12.